All right, welcome to Chapter 7. Chapter 7 is where it starts to get really interesting. We're actually doing reactions in this chapter. We're making new molecules. That's really exciting. We're organic chemists. We love making molecules. It's the best. So, first thing though is that it turns out that this chapter is really focused on alkyl halides. And what type of alkyl halide it is has a really large impact on the reactions that it will do. So the first thing we need to do is make sure everybody's up to speed with how do we classify alkyl halides as primary, secondary, or tertiary. So we have 3 halides on here. Take a minute, pause the video right now, classify them yourselves as primary, secondary, or tertiary, and then restart that video. All right, you guys did such a good job. This fluorine is on a carbon that's attached to 2 carbons, so we would call this a secondary alkyl fluoride. This bromine is on a carbon that's attached to 1, 2, 3 carbons. 3 carbons, that's tertiary. This is a tertiary alkyl bromide. This iodine is on a carbon that's only attached to 1 carbon, so this is a primary alkyl iodide. And like I kind of alluded to a minute ago, alkyl halide substitution has huge impacts on reactivity. So if we're having a hard time saying it's primary, it's secondary, it's tertiary, whatever, learning the reactions is going to be really hard. So make sure you understand this. Okay. Next thing we're going to cover is how do we name these things. So we've done a lot of IUPAC nomenclature. Everything has been alkanes so far, but now we have halogens on our molecules as well. And how do we name a halogen? And it turns out that halogen substituent becomes halo, like that Beyonce song, "See me a halo, halo, halo." You know what I'm talking about. See your halo, halo, halo. You got this. Anyway, so halo is for halogen, and each specific halogen has its own term. So fluorine would be fluoro. Fluorine. Man, I'm so embarrassed. I'm like, no, it's spelled like this. Fluoro, right? Man, sometimes you like don't. I'm so embarrassed. I'm so embarrassed right now. I just need to make sure. Fluoro. All right, thank goodness. That is how you spell it. Jeez, guys, I was really stressed out. It's getting hot. All right, we're good though. Okay, fluoro would be for fluorine. Chloro would be for chlorine. Bromo is for bromine. And iodine is iodo. So that's how we name these halogens as a prefix as part of a larger organic molecule. So yeah, spelling, man. It's that's the right spelling, I promise. I looked it up now, but for a minute I was worried. Okay, so how would we name this thing? So the parent chain is 4 carbons long. So 4 carbons long would be B-U-T, bute. It's an alkane still, so it's butane. So how do we name the substituent? Often people do an X for a halogen. So an X would mean any of the halogen types. Fluorine, chlorine, bromine, or iodine. X would be like any of them. They have very similar reactivity, so sometimes we'll just put an X instead. So this would technically be 2, we'll just say halo for that halogen, 2-halo butane. Are we done? Should we add anything? Anyone have any ideas? Oh yeah, in the back. Oh, louder? Man, you have such a quiet voice. They were saying in the back there that we need something to indicate this stereochemistry. Good job. So we would do our RS, same stuff. Any of the halogens is larger than a carbon, so that would be the first priority. This ethyl beats just the methyl for the second priority. This is the third priority, so 1 to 2, 2 to 3. That is clockwise. So this is R, 2-halo butane. Okay, so now would be a really good time for you guys to pause the video and name this second one according to what you've learned previously, because you have all the skills. All you're doing now is adding chloro, bromo, whatever to that. So, so do that. Pause the video, then come back. Boop, boop. All right. Well, you did really good. Nice job. So, how are we going to do this? We number to get the most substituents. 1, 2, 3, 4, 5, 6, 7. Most substituents in the longest parent chain, so that's 7 carbons long. So the prefix for that, or not the prefix, the parent name is heptane. So this is going to be heptane. But what is going to be in our prefix? We got a lot of stuff this time. We got a 2-methyl, a 3-ethyl, 4-methyl, and a 4-chloro. So we're going to alphabetize those things. The 4-chloro is going to be first. 4-chloro, because C is the first. Ethyl's next, so that'd be 3-ethyl. We have a methyl in the 2 and the 4, so it'd be 2, 4. And then what do we put in front of it? Yeah, dimethyl heptane. All right, and then we still have to do our stereochemistry, guys. So again, you guys should be making sure you can do this on your own. It's really important. It's especially important because we have an exam on stereochemistry soon. So this stereocenter, this is the first priority, second priority, third priority. That is S. This one, this is the chlorine is the biggest. That's the first priority. This is branched right there, so that's the second priority. This is the third priority. So that is, again, 1 to 2 to 3. Counterclockwise, this is also S. So how would we name this? This would be 3S, 4S, 4-chloro, 3-ethyl, 2,4, dimethyl heptane. So that's doing that. On the next page, you have another naming one. This is just a cyclohaloalkane. So I'm going to draw that right here. We'll just do our naming continued right there. It's a 6-membered ring. It's got a methyl. It's got a bromo. It's got a wedge like that to the isopropyl. Oh, I just gave away some of those things. But again, this would be a good time for you guys to practice this. You got to be able to do it by yourself. That's how you're going to do it on exams. So what is this one? This one, I'm not going to, let's talk through the beginning of it. Since you've already tried it yourself, you've already paused it, you've already unpaused it. So just like we always did with cycloalkanes, we number to give the smallest combination of numbers. So we would number around it like this: 1, 2, 3, 4, 5, 6. So that's a 1 bromo, 2 methyl, and a 4 isopropyl. Putting those in alphabetical order, the 4 comes before the 2 because I comes before M. So that would be 1 bromo, 4 isopropyl, 2 methyl, cyclohexane. We also need the stereochemistry, right? Same exact process as before. I'm just going to do this first, like the number 4. So it's kind of just important, guys, just to go back to our basics. How do we figure out what is the highest priority in number 4? So for carbon 4, so C4, our options are, we have this that's number 3 is technically a C that's bonded to an H, it's bonded to an H, and it's bonded to a carbon. This C here is a C bonded to an H and another carbon. H, H, and another carbon. So those two are, oh, see, yeah, we'll put the H here, and then we'll put another carbon here. So these two are technically tied right now. The other two things are a hydrogen. That's the lowest, so we're going to give that the 4th priority. And the other thing is a carbon that's attached to a hydrogen, a carbon, and a carbon. So this already wins 1st priority as well. So just looking one carbon out and what it's attached to, we would say that this is the 1st priority. This carbon here is the 1st priority. These two tied, so then we go one further. So yeah, this C is this C. So this carbon is now this carbon. This carbon is attached to a carbon, and an H. So that was on the top side. This carbon is this carbon. So this carbon is that carbon. So that carbon's attached to an H, and a carbon. So this CC beats this C. The two C's beat the C and an H. So this is now the 2nd priority, and this is the 3rd priority. So how do we do that again? We put the 4th priority is that hydrogen. We just said that this top side is the 2nd priority. This downways is the 3rd priority. So we would go 1 to 2 to 3. That is clockwise, so that is R. So that's how we did that one. You guys should be able to figure out the other two. Essentially this is going to be 1R. So if you haven't done it yet, oh shoot, I just told you one of them. But you should have done this for yourself, so give it another shot. But yeah, it's 1R, and then it will be 2R, and 4, what did we just say? R. So that is the stereochemistry around that cyclohexane. So that's how we name these halogenated alkanes. The same way we always name according to IUPAC, but now we just add this halo, halo, halo. Yeah, all right, bye.